Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be talking about the new way we handle our post-processors by using the machine ID. What exactly is the machine ID? Well, if we look what we had previously, we had a post-processor, for example the FNUC, and we use two files here. One called the FNUC GPP and one called FNUC Mac. Now in 2011 we've taken the Mac file and actually split it into two separate files. One being called FNUC.vmid, which is the ID machine, and another one called PRP. What exactly is the VMID? If I were to double click to open it up, you'll note that a table opens up in front of me, which is actually a lot more graphic. You can see exactly the name of the machine, options, devices in here, and you can see that there are devices that can be added as well. We'll go into that in a moment. We've also added another file called PRP. The PRP file is actually a file that has the rest of the information on the machine, such as the G-code information, what program number to start with, what cycles does it support, compensation yes or no. All of the options of the actual controller itself for the G-code is kept in the PRP file. Now let's open up our machine ID file and see exactly how this works. As you can see, in the left column over here, we have the first thing saying what is the actual name of the controller. In the right-hand column, it gives all the information about the machine itself. For instance, that the name is FNUC, the operation type, it's a milling machine, and the type of post-processor it used, which GPP file is actually going to be used. To change any of this, you just simply click on it, and if there's a drop-down folder, you can look at the drop-down folder that's over here. Now, underneath the FNUC, we have the next line called Options. In the Options, it tells us whether the machine has a dwell. We put a dwell time value. It has all the information of the machine stop, optional stop. To change them, again, just click over here. You can have a none or on. Another example, if we have a chip convoy, we can have it go whatever the options are that are normally available, either on, off, clockwise, counterclockwise, or off, or non-existent. And bed rinsing, all of these are added on over here. Now next, we have our devices. For example, we have our devices, our turret, where our spindle is located, and our table itself. If I were to click on the turret, it will give us all the information about the turret. For example, the name of the device called the turret, the motion direction. In this case, the motion direction is in the Z direction. As you can see, the X, Y are 0 and 1 is in the Z field, and the home reference point of that as well. We also have the turret's type called spindle, or we can change this to linear or rotary. We even have the holder type is over here. All the information that is needed on the turret is actually over here. Also note that the number of axes is also over here, and at this point we see here that this machine has 3 axes. If I were to click on the plus next to the turret, you see it also has its options, whether it's air, coolant, mist, all of these options are in here, and this actually controls the coolant in our program. The coordinate system, X, Y, Z, and its position. And now we get to the actual axis itself. We see here that we have 3 axes, X, Y, and Z. All of them are linear. If I were to open up the plus that's down here, we can see that we have here the X-axis, Y, and Z. And in the X-axis, for example, you can see that the X-axis type is a linear, moving in the X direction as shown over here, and it moves simultaneous. We have here whatever limit is necessary. For instance, I can change this to minus 5,000, and this one I can change this one 5,000 as well. interpolation step, how far each step moves, in this case 1 micron, the rapid feed and the minimum feed, as shown over here. All of this can easily be changed, as I showed you before. And since this does not spin, there is no minimum or maximum spin over here. Now, if we go into our z-axis, we have here also that it's linear, but the z-axis does have a spin rate. So we have here our maximum spin rate and whatever that machine supports. Now, let's say we want to add an axis. It's not a problem at all. All we have to do is right-click on axis, and we have the option here of adding an axis. For example, if I want to add a turntable, a 4th axis, I can call the name of this, let's say A, according to what is recognized by the controller. The axis type, in this case, is not linear, so I can open this up and change this into rotary. And then all of the rest of the parameters that are needed in this field. There are also other options that can be added in. For example, if there was a part catcher, all I have to do is drag this into the device area, and I've now added a part catcher to this as well. If I have some kind of special fixture on the machine itself, that would be on the form device, and I can drag it in there itself. And over here also I will have all the options that are necessary for that. Another important option that we have in Machine ID is submachines. Now, let's just take a quick look at this diagram that I have here on the screen. And as you can see, for example, in this mill-turn machine, which is an Integrex, we have here our upper turret and our lower turret, and our spindle, our main spindle, and our sub-spindle, or our back spindle. And you can see we can have different combinations of how they work. And this is what the submachines are. We can have one submachine of this turret working together with this head, or this turret working together with this head. And the same thing over here. We can have either this turret working with this head, or this turret working with this head. As you can see here, this is showing a diagram of this turret actually working together with this head, also known as the table. Now, let's take a look at the machine ID itself. Now, if we take a look at the machine ID, and in this case I'll be showing you the Integrex 200 machine ID, we have here our submachines, where the submachine in this particular case is made up of 3 different options. One, we have our lower turret, which is made of our lower turret and the table. Second one, called the first combination, made up of our head and our table. And we have another one here called the upper back, which is made up of the head and the back spindle. And if we wanted to add another one, we can just add another one by right-clicking over here and getting Add Submachine. Now, if we go over here on top, we can actually look at the machine simulation to see exactly how this is lined up. As we see here in our machine simulation itself, you can see that we have our back spindle as shown over here. We have the head turret, the bottom turret, and we actually have the spindle inside the head turret itself going in either way. Now, the combinations that we can have is, for example, this together with this, with the back spindle. We can have the bottom turret with the back spindle itself, or with the front one, which is another option. And the same thing with this, we can have that as well with this turret over here, with the actual front chuck itself. Now, the submachine is put into play. If I were to start an operation, for example, add milling, you can see we have here the submachines. And at this point, you choose which one of the combinations you will be using in this particular operation. And this is the one exactly that appeared inside my machine ID. Thank you for joining us on SolidCAD Professor. Take care and have a nice day.